today we're going to begin section 9.4. Ooh, this is actually 9.4, part 1. And we're going to be solving polynomials in factored form. We're going to learn what factored form means, but before we get there, there is a property and a definition that I want to share first. First, we have the zero product property. Now, the zero product property is something that you've known since elementary school, except now we're just going to put a name to it. Okay, so if A and B are real numbers, which is numbers that you deal with in every day, so if A and B equals 0, A times B equals 0, then either A equals 0 or B equals 0. Okay, that's saying that if you have any two numbers multiplied together and their product equals 0, that one has to be 0, or both. Okay, so if you multiply anything by 0, you get 0. That's the property that we're talking about right here. Okay? So along with that property, we have something called roots, which is what we're going to be solving for today. And the roots are the solutions of a polynomial function. Okay? So, in our first example, we have x plus 4 times x minus 2 equals 0. This is called factored form. Okay? If you recall what a factor actually is, when you have a product, you multiply things together. The solution is called a product. The things that you're multiplying together are called a product. They're called factors. So two things that you're multiplying together are factors. The answer when you multiply them is a product. So here our product is 0, and we have these two factors, x plus 4 and x minus 2. To find our roots, or the solution of this, we're going to take each factor and set it equal to 0. See, if A times B equals 0, then either A equals 0 or B equals 0. So if this is our A and this is our B, then we're going to say, hey, either x plus 4 equals 0, or we're going to have x minus 2 equal to 0. Okay, and then we just solve these for x. So if x plus 4 equals 0, we're going to use our inverse operation of subtracting 4. So we get x equals negative 4. And then here, if we're subtracting 2, we're going to add 2 on both sides. So x equals 2. We have two answers, x equals negative 4 and x equals 2. And then we're done. Okay? Over here, we have the same type of problem. So we have 2x plus 1 times x plus 7. This is our A and this is our B. So we're going to let 2x plus 1 equal 0 and x plus 7 to equal 0. Okay, notice that in order to use this property, we have to be set equal to 0. Okay, and we have to have factors. Alright, so to solve this one, we use our inverse operations going backwards of our order of operations. So first I want to take care of addition and subtraction. This is adding 1, so I want to subtract 1 on both sides, which gives me 2x equals negative 1. And then this 2 and this x are being multiplied, so I undo it by dividing. That reduces, so x equals negative 1/2. Okay? We love fractions. And then right here I have x plus 7, so I'm going to subtract 7 on both sides. So x equals negative 7. So our answers here, our roots, are negative 1/2 and negative 7. Okay? Now, we are going to talk about factoring. Alright, we're going to be starting to factor. This will be the bulk of this chapter. Okay? And factoring means that we're going to write a polynomial as a product. Okay, so when we have dealt with polynomials up to this point, we've had a lot of those monomials added and subtracted together. So we've had a lot of terms. Okay, now we want to write all those terms as things being multiplied together. Okay, within our factors, there can be addition and subtraction, but ultimately we want to see the polynomial written as things being multiplied together. Okay? So the first type of factoring we're going to learn, and then we're going to build off of this, is called the GCF factoring, or greatest common factor. Okay, you probably learned this a while back when you were middle school maybe. But the greatest common factor means we want to figure out what is being multiplied together to get each term, and then the biggest one, we want to factor it out. Okay? So here, for example, if we have 12x plus 42y, and we want to find the greatest common factor to write this in factored form, we need to figure out what factors are making up these things. So we want to essentially make a factor tree. So here we have 12 times x. 12 breaks up into 4 and 3, and 4 breaks up into 2 and 2. Okay, so 12x is really 2 times 2 times 3 times x. Okay, those are all of my smallest things. 42y is 42 times y. 42 is 2 times 21, and 21 is 7 and 3. So all of my smallest factors are 2 times 3 times 7 times y. Now to find the greatest common factor, we want to pick out factors that both of these share. Okay, so here we see that they share 2 and they share a 3. What is 2 times 3? It's 6. So we are going to factor out of both of them a 6. As soon as we factor out a 6, we're going to open up a parenthesis. And then we write the leftovers. Okay, so here if I have pulled out a 6, my leftovers are 2 and an x, or 2x. And then here my leftovers are 7 and y. Okay, and that is how you do greatest common factoring. We have pulled out the greatest common factor 6 and wrote the leftovers inside of parentheses. And now we have ourselves a product. Okay? Over here, we have 14y squared plus 21y. Okay, so 14y squared is 14 times y squared. 14 is 7 times 2. Y squared is y times y. So 14y squared we can write as 2 times 7 times y times y. 21y is 21 times y, and 21 is 7 times 3. So 21y written as factors is 3 times 7 times y. Okay, so now we need to figure out which ones they have in common, hence greatest common factor. So they don't share 2, they do share 7, and they also share 1y. So our greatest common factor here is 7y. Now I write the leftovers. In the first term I have a 2 and a y left, which is 2 times y, plus my 3 over here. So this is 14y squared plus 21y written as a product using greatest common factor. Okay? So since greatest common factor helps us write things in product form or factored form, we are going to use that to solve. Okay? So here we have these first polynomials. 2x squared plus 8x equals 0. Okay? We solve whenever we see an equal sign. Alright, this is already equal to 0, which is good, so now we want to try and use our zero product property. However, we have to write this as a product. So to write things as a product, we are going to use greatest common factoring. So here I have 2x squared. This is 2 times x squared, and x squared is x times x. So 2x squared is 2 times x times x. 8x is 8 times x. 8 is 4 times 2, and 4 is 2 times 2. So 8x is 2 times 2 times 2 times x. So what do they share? Here we share 2, and then we also share an x. So this can be written, I'm going to pull out my greatest common factor, and then write my leftovers. I have an x here, plus 2 times 2 is 4, equals to 0. Now I have a product. I have 2x times x plus 4. So now I can use my zero product property. So I'm going to take 2x and set it equal to 0. And then I'm going to take x plus 4 and set it equal to 0. And now you solve. 2 times x, I solve for x by dividing both sides by 2. So I get x equals 0. Yes, that is allowed. 0 can be an answer. And then here, I'm going to subtract 4 on both sides. So x equals -4. Okay? Using greatest common factors to solve. Last example, we have 3x squared minus 9x equals 0. So again, we're going to use greatest common factoring. We have 3 times x squared, and x squared is x times x. So I get 3 times x times x. Minus 9x, I have 9 times x. 9 is 3 times 3. So 9x is 3 times 3 times x. Okay? So my greatest common factor, I have a 3 and an x in both of them, which means I can factor out a 3x. And my leftovers, in the first term is x, I have a minus 3 equals 0. Okay, so using our zero product property, I take 3x, set it equal to 0, and I have x minus 3 equal to 0. So then I solve for x. I divide by 3. 0 divided by 3 is 0. And then I add 3. And x equals 3. Okay? That is zero product property, greatest common factoring, and putting them together to solve by factoring.